Welcome to this lesson on arithmetic and geometric sequences. An arithmetic sequence is a sequence that's created by adding or subtracting the same number to get to the next term. Arithmetic sequences are linear because you are constantly adding the same number. It's got a constant rate of change. For example, 6, 9, 12, and 15, you're adding 3. Add 3, add 3. The common difference is the number that's added or subtracted. To get to the next term in the sequence. So like 5, 10, 15, 20, you're adding 5 each time. 9, 7, 5, 3, you're subtracting 2 each time. A geometric sequence is a sequence created by multiplying the previous term by a number. Geometric sequences are exponential. So 2, 6, 18, 54. You're multiplying by 3 each time. And then the common ratio is that number that a term is multiplied by to get to the next term in the sequence. So 3, 15, 75, you're multiplying by 5 each time. That's your R. Okay, so let's determine whether each sequence is arithmetic or geometric. So 0, 5, 10, 15, 20. I'm adding 5 each time. That would be arithmetic. 3, 6, 12, and 24. I'm multiplying by 2 each time, so that would be geometric. Number 3, 0.5, 0.25, 0.125. This one I'm actually dividing by 2 each time. So that will be geometric. Multiplying or dividing is geometric. Or you can also say I'm multiplying by 1/2. That's the same thing. So your R would be 1/2. They're getting half the size. And then 20, 10, 0, negative 10. It looks like I'm subtracting 10 each time. So that's arithmetic. All right, number 5. Let's see. This has 1 block, 3 blocks, 5 blocks, 7 blocks. So I'm adding 2 each time. That is arithmetic. And then 1, 2, 4, 8. Looks like I'm multiplying by 2 each time. That would be exponential. Oh, sorry, it is exponential, but the type of sequence would be geometric. All right, let's continue on. Use the sequence to fill in the XY table and then graph. All right, so 2, 4, 6. It looks like we're just adding 2 each time. So 8, 10, 12, 14, 16. And then let's graph that. So 1, 2, 2, 4, 3, 6, 4, 8, 5, 10, 6, 12, 7, 14, and 8, 16. And I'm going to connect those so we can see it a little better. All right, use the table and the graph to answer the questions below. So, would a linear, quadratic, or exponential function be the best fit? Well, we can see from the graph this is definitely linear. And it's linear because I have a constant rate of change. This is an arithmetic sequence I'm adding each time. All right, which function would best fit this data? So B is out, that's quadratic, and then D is out, that's exponential. But A and C are both linear. A has a negative slope. That means the line would fall from left to right. So it's not going to be A, it's going to be C. All right, let's try one more. 2, 4, 8. So I'm not adding 2 each time. It looks like I'm doubling. So 1632. So let's graph this. Now look at your y-axis. It's not counting by 1s or 2s. It's counting by 4. So be careful. So at 1, I'm at 2. 2, 4, 3, 8, 4, 16, and 5, 32. Alright, so use the graph to answer the questions. Would a linear, quadratic, or exponential function be best? This is definitely that J shape of an exponential function. And that's because we are multiplying each time. It's a geometric sequence. Alright, which function would best fit? Well, A is linear, B is quadratic, C and D are both exponential, and they're both gross, so we're going to have to really look at this carefully. One thing you can do is take the table and start plugging in points, substituting in points, and see which one would work. So 2 to the x power, let's plug in 1. That does give me 2. 2 to the second power, that does give me 4. 2 to the third power, I'm just plugging in, substituting in these x values for this x, and seeing if it gives me my y values. And it looks like this one is going to be the one that fits. Okay, you can stop the video now and complete your practice.